Here I'm going to do some examples with stretches and compressions on the base functions y equals x to the 3. When you look at these two equations, out of all of the base functions you've seen before, they should look to you the most like y equals x to the 3. You shouldn't think about the root x, x squared, 1 over x, absolute value of x. None of that look similar to the function that we have here. So the base function is y equals x to the 3. I want to do these transformations on x to the 3 and then do a sketch of it. So when you see a 3 right after the equal sign, that tells you the y values are going to get multiplied by 3. And we call that a vertical stretch. So first, we have a vertical stretch by a factor of 3. Y values are multiplied by 3. Next, inside of the brackets, you see a quarter in front of the x. You will do the opposite of that. Even though the equation says a quarter, we are going to think about multiplying x by 4. And when you multiply something by 4, you make it larger, and that's called a stretch. So we have a horizontal stretch by a factor of 4. 4 comes from flipping 1 over 4. So the x values are going to be multiplied by 4. These are the two transformations I want to apply on the x cubed function. So let's do that. We have y equals x to the 3, the points x, y, -2, when x is -2, y is -8, when x is -1, y is -1, when x is 0, y is 0, when x is 1, y is 1, when x is 2, y will be an 8. Okay, again, these are the key points on the x cube function. Let's see what we are doing to x. When we look at the transformations, let's see, we wrote down that there is a horizontal stretch by a factor of 4, that the x values are multiplied by 4. Again, this is counterintuitive. That's not what the equation says. I know that, but that's what the math will tell you. The x values are all going to get multiplied by 4. So that's what I show in the mapping rule. 4x. The y values. We are saying there is a vertical stretch by a factor of 3. Y values multiplied by 3. Okay, so 3y. Let me first do the x's. I multiply all of the x values by 4. So -2 becomes -8. -1 becomes -4. 0, 0 times 4, still 0. 1 times 4, 2 times 4. These are the new x values. The y values, they're all multiplied by 3. -8 times 3. -1 times 3. 0 times 3. 1 times 3. 8 times 3. These are the new key points. And that's the points I'm going to plot over here. Let's see. -8. Let's say -8 is somewhere here with a -24 down here. -4 with a -3. 0 with 0. 4 with 3. And then 8 with 24. Let's say 24 is up here. And then I connect these 5 points. And there's my graph. Let's move on to D. If C didn't make any sense to you, maybe D will make a little bit more sense. In C, I had the 3 right after the equal sign, which meant that the y values get multiplied by 3. So we called it a vertical stretch. In D, I see a 1/2 right after the equal sign. So to me, that would mean that I'm multiplying the y values by 1/2. When you multiply y values by 1/2, you are making them smaller. So it's called the vertical compression. Vertical compression by a factor of 1/2. Next, in part C, inside of the brackets, I had a quarter. We said you have to flip it and think about multiplying the x's by 4. Multiplying the x's by 4 was called the horizontal stretch. But now I have a 5 that I have to flip. And just think about it. Think about this. When you flip a 5, what does it turn into? Flipping a 5, which by the way is 5/1. It becomes 1/5. So instead of doing a horizontal stretch, when you flip a 5, it becomes 1/5. And by multiplying a number by 1/5, it becomes smaller. So I'm going to call it a horizontal compression. Numbers get smaller, it's a compression. 1/5. Okay, so first transformation is telling me the y values are going to be multiplied by 1/2. The second one tells me the x values are going to be multiplied by 1/5. Again, keep in mind that multiplying by 1/2 is the same as divide by 2, and multiply by 1/5 is the same as divide by 5. I'm going to take these same 5 key points, right? These haven't changed. I'm still transforming the x cubed function. So I still use those points, but I'm going to be using new mapping rule to get my new points. Vertical stretch by a factor of 1/2. It says vertical compression by a factor of 1/2. So 1/2 y. Horizontal compression by a factor of 1/5. So the x values are multiplied by 1/5. So that's going to be -2/5, -1/5. 0 times the 5th is 0. 1 times 1/5 is 1/5. 2 times 1/5 is 2/5. And then 1/2 of all of the y values. So half of all of these, 1/2 of -8 is -4. Half times -1, half times 0, half times 1, half times 8. These are the new points I want to plot to give me the new graph. Let's see. -2/5. If you don't know what -2/5 is, you can use a calculator. It's -0.4. So it's before we get to 1. So like right here. With a -4, 1, 2, 3, 4. So that's down here. -1/5, even smaller, with a -1/2. That's right there. 0, 0. And then 1/5 with a 1/2. And then 2/5 with a 4. Okay, so it's a very narrow type of looking graph because of all of the compressions we applied. But this is your graph. The y values are either divided by 2 or multiplied by 1/2. Again, I'll emphasize that you should be comfortable with writing it either way. Multiplication by fractions or divide by whole numbers, they mean the same thing. And once you apply the mapping rule on the key points on your base function, you connect them and there's your new graph.